right, everybody say hi, Remington. Oh, they are going to say it. Okay, all right. Okay, factoring polynomials. We're only doing one section today, 0-3, but this is a doozy. Not a doozy, it's fine. But this section, when we're factoring, I no lie, we will do this like in 6 different sections from here to the end of the year. So, if you pick up what we're learning today really easily, then it'll just make everything super easy from here on out, because we'll do this literally like five or 6 more times. It's gonna be awesome. So, I have kind of a weird homework assignment going on here, because there are 4 different methods that I have for factoring, okay? And I'll label what these are, but you can kind of see the categories. I have like this category, this category, this one, this one, this one. And so I made it a little easier on the homework assignment because I tell you which method you need to use. Does that make sense?
Can I please have Addison Cox, Kate Dunn, Cody Eckstein, Liliana Garcia, Holden Gilbert, Trent Hinkle, Caleb Hessman, Lillian Kent, Casey Kirshner, Tammy Kriz, Grady Kuchera, Caden Lurie, Brinley McNeil, Hunter Meyer, Easton Roberts, Addison Spencer, and Ryder Zimmerman come to the office.
Okay. All right. So I have the 4 different categories labeled out for you, so you don't go into this homework assignment blindly like, what method do I use? I kind of like help you out with that. Okay. So it's a little bit easier. Okay. When we get to like the couple times down the road when we're factoring, you'll have to decide that for yourself, but it's not too bad. Okay. All right. So the first method, put a number 1 on example 4. Okay. I don't know why it's labeled example 4. I don't know. It's really example 1. But this is the greatest common factor method, or GCF. If you need to write out greatest common factor, you can, but this is the GCF, or greatest common factor method. Now, you know that you need to use this method when terms have something in common, like that you can take out. Okay, so I only have 2 pieces in this first example, 4a squared and 8a, but is there something that I can take out of both of those pieces? 4a. They're both divisible by 4 and a. Now, when you take it out, you don't throw it in the garbage. It comes out front, and you do a parenthesis of what's left over after you take that out. Does that make sense? Okay, so we're taking 4a out, all right? If I take 4a out of 4a squared, what's left over? A. Just a, right? Okay, and if I take 4a out of 8a, what's left over? 2. You're like dividing, right? Okay, now, if you're confused and you're like, ooh, did I do it right or not? You can easily like distribute this back through and see if you're right. Okay, so 4a times the a, does that make 4a squared? Yes. 4a times 2, does that make 8a? Yeah, so we did it right. We're done. That's the greatest common factor method. Pretty easy. Not too bad, right? Okay. All right, method number 2 is something that I call the simple trinomial method, and I abbreviate this with an S and a T. Okay, so on that homework assignment, it's labeled ST as the second category. Okay, all right, now we're going to break this down and I'll show you why it's simple trinomial. Okay, trinomial, you guys said yesterday, means 3 pieces, right? 1, 2, 3 pieces. All of these examples have 3 pieces. The way that makes it a simple trinomial is that the first term is just x squared and there's no number in front of it. That's what makes it pretty easy. It makes it simple, right? Simple trinomial, it's just an x squared, no number in front of it, right? I'm going to skip down to complex trinomials because that's what this is. Trinomial, there's 3 pieces, but in a complex trinomial, there is a number in front, and it's a 6 in this case, right? So that's what makes this one a complex trinomial versus a simple trinomial, okay? Simple trinomials are really nice. Here's what you do. They're like super quick and easy. We're going to have 2 pieces that it's going to factor down into, okay? And my factors are going to be determined by this number and this number. All I'm doing is trying to find the 2 numbers that multiply to give me a positive 6, but when I add them, give me 5. Can you think of numbers that you can multiply to get 6 but add to get 5? 3 and 2. And it needs to be a positive 3 and a positive 2, right? Okay, so I write it as x plus 3 and x plus 2, okay? 3 times 2 is 6, 3 plus 2 is 5. Done. That's it. That's factoring a simple trinomial, okay? Let's do one. Part B is a little bit harder. We have our two bubbles again. I'm trying to multiply to give me 12, but add to get, and don't forget about the negative, -8, okay? Now, some of these might be a little bit harder to think of, so if you need to like write out the factors of 12, 12 would be like 1 and 12, 2 and 6, or 3 and 4, right? Make sense? Okay? Now, which one of those groupings is going to give me -8 when I add them?
-6 and -2.
Yeah, -6, -2. 2 and 6 are going to give me 8, but if I want them to be the right sign to make -8, they have to both be negative. So what do my two groupings look like?
X minus 6 and
X minus 2, X
X minus 6.
minus 6. I heard somebody say X minus 6, X minus 2. If they put them in the other order, is it wrong? No, it doesn't matter, right? So that's fine. That's all, right? Okay, next one, C. We're multiplying to get -15, excuse me, and adding to get 14. Multiply to get -15, add to get 14.
-1 and 15.
Yeah, so we've got 1 and 15, or we've got 3 and 5. Those are the only combinations we have. So 15 and 1, and if I want +14, it's got to be -1, +15, right? Or vice versa. So my two groupings, X minus 1, X plus 15, or X plus 15, X minus 1. Doesn't matter how or what order you put them in. Have you guys done this before? Yeah? Okay. Okay. Good, good? Happy with this? Not too bad, right? We like these. Okay. This is the hardest one, the complex trinomials. These are icky. Ask any of the upperclassmen, they're like, we don't want to do this. We did this in my calc class today. We went over complex trinomials again, just as a review. Like, they're kind of a doozy. So I'm going to write you out steps. There's kind of like 4 steps-ish for doing this. And if you follow these steps, you'll probably get through it. It'll be fine. Okay? Again, complex trinomial, because there's a number in front of the x squared. That's not, yeah, like it's just a number in front of the x squared. First thing is we want to multiply A and C together. And now you're lost. You're like, what the heck does A and C mean? Oh, man. What's A and C? You have any idea?
6 and -.
Yeah. 6 is A, 7 is B, and -3 is C. So if we multiply A and C together, step number 1 would be 6 times -3, and that's going to give us -18. Perfect. That's step number 1. Step number 2, I'm going to say find the factors. Okay? So just like we did in simple trinomial, we want to multiply to get -18 this time, but when I add them, give me 7. Yeah? Multiply to get -18, add to get 7. Yes? Okay, so step number 2, I'm going to list -18 out over here. That would be like 1 and 18, 2 and 9, 3 and 6, and that is all. Which combination is going to give me 7? Yeah, now I want a +7, so I'm going to use -2, +9, right? Does this make sense? Are we lost yet? Are we doing okay? We're going to do another one right after this. I have 2 examples for complex trinomials, so if it's a little rough, we'll get the hang of it in the next one, okay? So -2, +9. All right, this third step, so we found our factors, our -2, +9. Okay, step 3 is write out 4 pieces. Okay, write out your 4 pieces. So step 3, I'm going to write step 3 over here because I need a little bit more room. Pieces. Okay, step 3 over here. All right, we originally had 6x squared plus 7x minus 3. That was the original problem, right? But now I'm going to make that same thing, but make it look like 4 pieces. So the 6x squared is going to stay. The -3 is going to stay, but that 7x in the middle is going to split. What's it going to split into? -2x plus 9x. These numbers that we came up with over here, right? It splits into those 2. Okay? Have we done this before? Kinda. It's like, it's been a while, right? Okay, last thing, step 4, is what's called factor by grouping. Factor by grouping. Okay? I'll let you write that down. Factor by grouping. Okay? And that is this. Step 4, here we go. We're going to group the first 2 chunks. We're going to group the second 2 chunks together. Okay? This is step 4. Out of that first chunk, 6x squared minus 2x, what can you pull out like a greatest common factor? 2 and x. If we pull a 2x out of 6x squared, we'll have 3x left over, right? What if we take a 2x out of a 2x? We have to have a spot to put in its place. We have to put a 1 there, right? Because if I don't put that 1 there and I try to multiply it back through, that second term is gone. So I have to hold a place value, so minus 1, okay? Then let's go to the second piece. What are you going to pull out of 9x and minus 3? We're going to pull a 3 out, okay? Leftover is 9x divided by 9, or divided by 3 is 3x, and negative 3 divided by 3 is negative 1. Okay, I know I did it right. Do you know how I know we did it right? You see this? Those two have to be exactly the same pieces, right? That's how you know you did it right, okay? So, last step is rewriting everything. I don't really even call it a step because it's kind of the same as what it is before. But that piece that shows up twice, we're going to write it down once. There he is. And then the other group is what's left over, right? So 2x and 3, but what sign is in front of that 3? A positive 3, right? So this is 2x plus 3. That's my other grouping. And we're done.
Okay, I kind of remember.
Kind of coming back to you. We're going to do another one of those just to kind of solidify it before I leave you on your own to do homework and stuff. Okay? All right. This one, example 7, is also a complex trinomial. How's come it's complex? Because there's a 4 in there. Okay, so step number 1, we multiply a and c together. A is 4, c is 25. 4 times 25 is 100. Okay, now I'm finding I want to multiply to get 100, but when I add them, give me 20. You multiply to get 100, but when I add them, give me 20. If you can't think of it, just start listing. 1 and 100, 2 and 50, 4 and 25, 5 and 20, 6, 7, 8, 9, 10, and 10 and 10. That's the one. Okay, so that 20 is going to split into 10 and 10. All right, we're writing our 4 pieces. So the 4x squared and the 25 stay. Are we confused yet? Are we doing okay? Are we okay? Yeah? Okay, that 20 is going to split plus 10x plus 10x, right? Those are the two that we said are going to be the ones that we want, right? 10x, 10x. Now what? Group them. Factor by grouping. Group and group, okay? So out of 4x squared plus 10x, what can we pull out of there? Like 4 and 10, what are they divisible by? 2, and we can take out an x, right? So 2x goes in there. If I take 2x out of 4x squared, it's 2x, right? And if I take 10x and divide by 2x, it'll be plus 5, yeah? Now again, you can do the same thing like greatest common factor if you want to check to see 2x times 2x is 4x squared, 2x times 5 is 10x, right? You can check to make sure that you did that right, okay? Out of the second grouping, what can you pull out? 5. A 5. So I'm going to do 5. And 10x divided by 5 is 2x. 25 divided by 5? Well, it better be 5 because it's got to match this guy, right? Like we know that, okay? Now, 2x plus 5 and 2x plus 5, those guys match. So I'm going to list them. 2x plus 5, okay? And then my second grouping is what's left over. This right here, 2x. Hey, 2x plus 5. They're both the same group.
Would you be able to write it like squared?
You betcha. 2x plus 5 squared, okay? Now, I skipped over this heading just because I wanted to see if you guys caught up on this. This is something called a perfect square trinomial, right? And perfect square trinomials are ones that have the same groupings, so you can write it like this if you want. Yeah. If you write it like this, it's not wrong. You can leave it like that too. But 2x plus 5 squared is how you can write it easier. Okay? Good? That was complex trinomial. That's the third method. Last method is my favorite of all. I'm going to do this one, and then I'm going to do another one. I'm going to do, let's say, like 25x squared minus 16. I'm going to do that one too. Okay? So I'm going to add like a c onto here. This is step number 4, and this is called a difference of squares. It's DOS. Difference of squares. A difference of squares. This is my favorite of the 4 methods because it's super fast and easy. Difference of squares. Okay, now here's how you identify a difference of squares. What does the word difference mean? Subtraction. Okay, so in both of these problems, do you see subtraction?
Yep.
Minus, minus. If it's plus, it's not a difference of squares. It has to be a difference. Difference means minus. Has to be. That's a difference. And squares. What's a square? Like as in terms of numbers, not like the shape of square. What's a square in terms of numbers?
Multiplying something by itself.
Yeah, like 2 squared is 4, so 4 is a square. 3 squared is 9, 9 is a square. 25, 16, 36, 49, 81, 100. Those are all squares, right? Perfect squares. So I look at this number, 4, and I say, can you take the perfect square root of 4? Yeah, the square root of 4 comes out nicely. Can you take the square root of x squared? Like, is there something you can multiply by itself to get x squared, right? What do you take times itself to get x squared? X, right? X times x is x squared. So those are both perfect squares. Let's look at this one. 25x squared. Okay, what do you take times itself to get 25x squared? 5x times 5x will give you 25x squared, right? What about 16? 4 times 4, right? Okay, so here's the difference of squares. Blink and you miss it because it's really fast and easy, okay? Difference of squares is kind of like simple trinomial. You'll have those 2 little groupings. So I'm just going to start them there, right? And then I look at this and I say, what's the square root of x squared? X. So I put x here and I put x here, right? What's the square root of 4? 2. So I put 2 here and 2 here. One of them is plus and one of them is minus. That's it. That's the difference of squares. So nice. Okay? Let's do the other one. All right? 2 groupings. What's the square root of 25x squared? 5x and 5x. Okay, what's the square root of 16? 4 and 4. One of them is
Positive.
plus, one of them is minus. That's it. That's the difference of squares. Now, let's say I wanted to like check my answer, like, you know, like this ends up breaking down into that. What can you do to check your answer?
Foil.
You could FOIL this out, right? Like what we did yesterday. FOIL and see if it comes out to be this. Now, how did we get just 2 pieces then? You know what happens to the middle 2 pieces? They cancel each other out when you're multiplying that back together, right? So that's why we only have 2 pieces rather than a trinomial, right? Okay, because the plus 4 and the minus 4, like it ends up being 20 actually, but they cross each other out and then you don't have that middle term. Okay, good? Make sense? Good? Okay, so these, I don't know, 9, 10, 11 problems, and then I have them listed out which one is a which.
Students, over the weekend, be
short
sure to
period,
charge your Chromebooks out 100%. Also, make sure that you are checking for updates. If you go to About Chrome, it'll take you to that update page. I believe the current Chrome version right now is set at 104. So make sure you get that updated and charged over the weekend. Thank you. Have a good weekend.
Students, if you did not get your Chromebook today, it's either because I do not have your paperwork turned in or it is not paid for yet. If you have any questions on that, you can stop by the office. Otherwise, be sure and have your paperwork here by Monday.
Usually you have more time to work than this, like in class, because the bell's been ringing like 2 seconds, so, but, sorry, short periods, kind of silly. Okay? Is that all stuff you've done before? Yeah. Oh, shoot, hi, Remington, goodbye, Remington.